In the previous section, we have discussed about the concept of Laplace transform, region of convergence, and the property of region of convergence. In today's lecture, we are going to discuss about the Laplace transform of some basic signal, and before that, we discussed about the S-plane and pole 0 of the system. As we know that the S-plane where S is nothing but sigma plus j omega, where the sigma is the damping factor and j omega is the frequency, and in this sigma represents the real axis and j omega represent the imaginary axis. And when we plot a plane where the real axis is sigma and imaginary axis is j omega, then this plane is known as the S-plane of the system. And in this plane, basically we plot the 0 and pole of the system. Then the question is, what is 0 and what is pole of the system? As we know that the LTI system, let us consider this is the LTI system. This is input signal and this is output. Input is represent the ST and output is represent the YT, but the system behavior is represent the ST. When we take the Laplace transform of the system, then YS we will discuss in the next, but for this discussion we just consider it. The output of YS is nothing but HX multiply with HX. Okay, therefore the HX is nothing but the YS Laplace transform of output divided by the Laplace transform of input, and this HS is known as transfer function of the system. Okay, this HS or the system behavior is represented in term of the polynomial equation. This is the output Yx and this is the input Sx. Okay, Laplace transform of it is a Laplace transform of output, and this is the Laplace transform of input. Okay, when we solve this equation and represent in term of numerator and the denominator, then this equation of this transfer function it look like this. And when we found this from the above polynomial equation, we know that the maximum power of upper numerator is the m, and in the bottom side the maximum numerator is n. And from the polynomial we know that the maximum power represents the root of this polynomial. Therefore in the numerator the maximum pole is maximum root is m, and in the denominator the maximum root is n. Okay, and when we find this the root of this equation, then we have two possibilities, uppercase and lowercase. When we put the for example in uppercase, these root are s equal to z1, s equal to z2, s equal to zn minus m minus 1, and s equal to s z s minus zm. And if these root are put in this equation, any of this root, when we put in this equation, then we got the when we put this into the equation, then we got this transfer function become 0. Therefore if any root z equal to z1 s is equal to zi, for which numerator equal to 0 and the transfer function vanishes is known as the 0 of the system. Therefore, the upper portion or the numerator is known as root of the numerator is known as the 0 of the system, and it is represented by the circle 0. Okay. Similarly, from the lower side or denominator side, when we put this the lower root, which is nothing but the p1, p2, pn minus 1 and pn, when we put this root in the transfer function, then the transfer function become infinite. Therefore, when we define is, if the root s is equal to pi, for which denominator polynomial become 0 and the transfer function become infinite, is known as the pole of the system, and it is represented with the cross. Okay. In this S plane, we look that this represent the 0 and this represent the pole. Mean the 0 represented by the circle and the pole represented by the cross. Okay. Then our first question is, next topic is the Laplace transform of some basic signal, and our first question is Laplace transform of impulse signal. Okay. The Laplace transform of impulse signal, as we know that the impulse signal is only defined for the for t equal to 0, and we know that if we integrate for the Laplace transform, we know the formula is t integral from minus infinite to infinite xt e to the power minus s omega t, when we put xt equal to del t, and we know that the del t defined only for the t equal to 0. Therefore, the this t equal to 0 put into e to the power s into 0, then this become 1 and integral of del t become 1. Therefore, the resultant become 1. Therefore, the Laplace transform of del t become 1. But the next question of ROC, what is the ROC of the system? Okay. For this, we know that the ROC defined when this integral is converged or less than infinite. When for the ROC, we find the integral xt, magnitude of this xt e to the power sigma t, and when we put del t, then the t is equal to 0 put in the side, then this equation become 1, and it does not depend the any value of sigma. It does not depend the any value of sigma. Therefore, as this integral is always equal to 1 and it is less than the infinite, and it does not depend the sigma. Therefore, the ROC is entire plane, and when we plot in the z plane, then ROC is defined as the entire plane of the system. Therefore, the unit Laplace transform of impulse response is nothing but the 1, and the ROC is entire plane. Okay. Next, the next signal is unit step signal. When we put this ut in this equation, then we know that the unit step signal is basically define the limit of this integral, and this integral become 0 to infinite, and when we integrate it, it become e to the power minus st divided by minus s, and the limit from 0 to infinite. When we put it, then we got e to the power minus infinite minus 1 divided by minus s. And for the defining the ROC, the one basic concept is when we put when we put limit infinite, then we have to take consideration or notice is this infinite is minus side or is this infinite is positive side. This is one important factor here. Then the integral become 1 upon s. Okay, but the R for the ROC. When we integrate it, okay, when we integrate it, here we put generally we put infinite, and as multiply with infinite, then it become minus infinite, but it always also depend on the value of sigma. Okay, as the value of sigma is must be less is have two possible term. One, the value of sigma is less than 0 and value of sigma is greater than 0. Okay, let us consider one point when the value of sigma is minus for the less than 0 it is minus 3, and for the greater than 0 it is a plus 3. Okay, then when we put the limit into the equation, then 1 upon minus 3 minus plus 3 and e to the power minus minus plus 3, and it is become the positive infinite. Then e to the power positive infinite means it is a infinite, then the integral does not converge, therefore Laplace transform does not converge. Okay, for the sigma equal to positive 3, therefore this limit, when we put this limit, the e to the power minus 3 into infinite, then minus and plus, then e to the power minus infinite. Here e to the power minus infinite means it equal to 0, therefore this equation becomes 0 minus 1, then minus minus plus, and it becomes 1 by 3, and it is definitely it is less than infinite, therefore Laplace transform exists. And we got one point here, that the Laplace transform exists only for lambda is greater than 0, and it does not exist for lambda for sigma is less than 0, and this defines the ROC of the system. Then when we transform this Laplace, when we take the Laplace transform of ut, then it is equal to 1 by s, and the ROC of the system is sigma sigma is greater than 0, or it is also known it is also represented as the real term of s is greater than 0. Okay, the one point is also should notice here that this ut is right sided signal, means it is defined for t greater than 0. Then if it is infinite duration, okay, as we learn in the property of 4 of ROC, that if the signal have the right sided if the signal is right sided and it is defined for infinite duration, then their ROC must be right sided and infinite, it is right sided. Okay, then next topic is when we revert it. When we revert it means it is defined for the left sided. Okay, the next question is to find the Laplace transform of u minus t. Okay, and similar cases we put this, and our limit, when we put it is a positive, and it become a it is also become 1 upon s. Okay, but this become 1 upon s only when when we define the ROC. Okay, we put it and 0 minus n, and when we apply, then it depend upon the value of sigma. Okay, this value of sigma also here two possibility, one is sigma is less than 0 and one is sigma is greater than 0. And for the consideration, we consider one value sigma equal to minus 4 and one value sigma equal to 4. When we apply this minus 4 and minus, and here the infinite is positive, then the minus and plus become the minus infinite, therefore the this term e to the power minus infinite become the 0, and the whole integral or the summation become the 1 by 4, and it is definitely less than infinite, and it is the Laplace transform exists. But for the positive term, as it is also positive and this sigma is positive, then the infinite term is become positive. Therefore, we know that the e to the power infinite become the infinite, then their summation become infinite. Therefore, Laplace transform does not converge. Okay, then here we got one point that the Laplace transform of e to the power minus t equal to minus of 1 upon s only when the sigma value is less than 0. Okay, one point is also noted that if this signal u minus t is left sided signal, okay, and the left sided signal, then ROC is also left sided. It is left sided and infinite duration, therefore the ROC is also left sided. Okay, the next topic, the next question, when we summarize this all the thing, then ut of Laplace transform of ut is 1 upon s and it is ROC is sigma greater than 0. Second, Laplace transform of u minus t, which is left sided signal, it ROC become minus 1 by s, its Laplace transform become minus 1 upon s and ROC is sigma less than 0. And when we transform this minus to the left sided, then the minus u minus t equal to 1 upon s and ROC is less than 0. Then as from this conclusion we notice that the Laplace transform of ut and minus u minus t has the same Laplace transform, but difference is only for the ROC. It is used case in the inverse Laplace transform. Okay, when we take inverse Laplace transform, then ROC is most important case because the multiple signal having the same Laplace transform but only difference in the ROC of the system. Okay, the next point, when we multiply with the signal with e to the power minus at. Okay, this is the one case of property, but we consider here the e to the power when we multiply e to the power minus at and taking the Laplace transform, then this consideration this multiply with e to the power minus s and it become e to the power minus s plus a. And when we resolve this, then we got one point that it is nothing but Laplace transform, but s is replaced with s plus a. It means when we multiply e to the power at, then it reflect it directly obtained by the Laplace transform xt when s is replaced with s minus a. Okay, when minus apply here, then it is plus. When plus apply here, e to the power plus at, then it become s replaced with s plus minus a. And ROC is also here. When it is minus, then ROC here is s plus a, and when it is positive, then it is a minus. Okay, we consider some question based on this. First, Laplace transform of e to the power minus at. As we know that the Laplace transform of ut is nothing but 1 upon s and ROC sigma is greater than 0. Okay, then when we multiply e to the power minus at, as we know from the previous property, when minus at is multiplied, then s is replaced with s plus a. Therefore, this s replaced with s plus a. Okay, and ROC, as here sigma is nothing but the real term of this s, it also not represented with real term of s is greater than 0. Therefore, in this case also the ROC is nothing but the s plus a is greater than 0. Therefore, the Laplace transform e to the power minus at ut is nothing but s plus a, and the ROC become sigma plus a is greater than 0, or the sigma greater than minus a. And it is defined in S plane. The minus a is left sided and it it is as it is a right sided signal, or it is a ROC is defined when the sigma is greater than minus a, therefore this region. Okay, as it is a energy signal, therefore the Fourier transform is also exists here. And we all just put s equal to as we discussed earlier, the from the Laplace transform we also we also obtain Fourier transform only when we put the sigma equal to 0. When we put sigma equal to 0 or s is replaced with j omega, then the Fourier transform is directly obtained. Therefore, the Fourier transform of e to the power minus at ut is nothing but 1 upon j omega plus a. Yeah. Okay, the next question is e to the power minus at ut upon e to the power minus at ut, Laplace transform of e to the power minus at ut. Okay, it is same as the previous case. When the minus term is applied, then here become positive. Then when plus power is applied, then it become minus. Therefore, the ROC is also s minus a, and sigma is sigma minus a is greater than 0. When we transfer this minus a to the right side, then the sigma become greater than a. Okay, when we plot it, then a is this side and the ROC become right sided. As the signal is right sided, then the ROC is also right sided of the A. Okay, and we notice that this signal is exponentially increases and their convergence is not possible. Therefore, the Fourier transform of this signal is not possible. Okay. For the next type, when we apply in the left sided signal, okay, e to the power minus at u minus t, and when we transform it, as we know, in the first case e to the power minus at become 1 upon s plus a. The same case is there, only difference is the t is replaced with minus and magnitude is also reversed. Okay, but as we discussed in the previous discussion, the Laplace transform of both the cases is the same. Just a minute. Okay, then the Laplace transform of e to the power minus at ut and e to the power minus e to the power minus at minus t is the same, and it is s 1 upon s plus a. But the difference only in ROC. ROC here is less than 0. Okay, then it is defined for sigma when the sigma is less than minus a and the ROC is left sided. Because the signal is left sided, then ROC is also left sided. And in the last case, okay, and the Fourier transform is also not existed because this is exponentially increasing or decreasing. But when we go to the minus infinite side, then the magnitude become infinite and their integral become infinite. Therefore, the Fourier transform of this system is not exist. In the fourth case, e to the power minus at u minus t and magnitude is minus. Okay, this is a limited signal because when we move towards the minus infinite, it is tends to 0, and when we goes to the infinite, it is maximum value is minus 1. Therefore, it is limited signal and the integral is converged, and it is nothing but the same as Laplace transform, same as the signal e to the power minus at ut, and output is Laplace transform 1 upon a. One point is there, one point to note there. If we minus, okay, if we minus the unit step, and when we put second minus to the magnitude, then the output is positive. Okay, then output is same as the previous section. Look at this. The Laplace transform is the same as the previous case, but only as it is left sided, their ROC is also left sided, and the sigma is less than a, and then ROC become the left sided. Okay, less than the a, positive a. And as this is converse, their Fourier transform is also obtained. Just put s is replaced with j omega, then the Fourier transform of e to the power minus at e to the power 8 minus e to the power at u minus t Fourier transform we directly written as 1 upon j omega minus a. Just put s equal to j omega. It is enough for today's lecture. We will discuss in the next session the Fourier transform of other different signal and the inverse Laplace transform. Thank you.